Hello there and welcome back to the channel. So, in this video we'll go over the most important part of working with Git. If you understand how Git works locally, how to create branches, how to merge, rebase, resolve merge conflicts, etc., then working with remote repositories and collaborating is very easy. So let's start from scratch and fire up our terminal and create a directory for our project. Today we'll call it Climber, a new app for climbers. Now run git init and notice that now you have a .git directory in there. Now we can run git status and git response saying that there is nothing going on. Clearly we haven't done anything yet. So let's create a file, say file1 with content line 1, run git status again, and git says that the file is untracked. So let's tell git to track it with git add file1 and check the status again. Now we have changes to be committed, so let's commit that with git commit -m and a message say first commit. Now we're back to a clean state, a clean working directory and nothing to commit. This -m first commit part is the commit message. Try to have better commit messages than we'll be using in this video, okay? Okay, so let's do that again. Let's add line 2, check out the status, and Git knows that we changed the file. So let's add that change with git add file1 again. You might be wondering why we need to do this git add operation instead of committing straight away. When you do git adds the file to what's called the staging area. The staging area is where you craft your commit. A commit is an important thing and it's telling the story about your project. So you need to have a good level of control over what is going into your commit. I will create a full video about the staging area quite soon, so subscribe and don't miss out. But here, for now, we'll commit what we have added to the staging area. Git commit -m, add a second line. And git status tells us that we're back to a clean state. This is the main flow. We start with a clean state, add commit, and we're again clean. Okay, so now that we have two commits, we have a little bit of a history going on. Let's do git log and we see the two commits that we've done. So now let's add a third line and add and commit as usual. And now we see that in the log. Notice that commits have this long ID. This is the so-called checksum. For now, you need to know that it exists and uniquely identifies the commits. But if you're more curious, I have another video that explains it exactly what it is, so watch it if you're interested. Now, where Git really shines is when we start creating branches. So let's create some branches. Super easy. Just type git branch and then give your branch a name. Say banana. It can really be anything. Now do git log and we see at the top that we have this banana thing here. This means that the banana branch is at that commit. We also have this other branch called main. There is absolutely nothing special about this main branch. As far as Git is concerned, it is the same as our banana branch. We can also see that this main branch is our current branch because head is pointing to it. Now, head is where we are, and we can change where we are with git checkout, and nowadays there is a new command called git switch, which does the same thing as git checkout in this case. So to switch from the main branch to the banana branch, we just need to git checkout banana. Now, git log tells us that our head is at banana. Let's create another branch just for fun. So git branch apple, git log, we have a new branch called apple. If we want to, we can switch to the apple branch with git switch apple, and now we are on apple. Well, you get the point. So now that we are on this apple branch, let's add the word apple to the file, then git add and git commit and then git log. The apple branch has advanced, but main and banana stayed behind. Let's switch to banana and bling, the apple line disappeared. Let's switch to apple again and the word apple appears again. Check out banana, it disappears. This is version control. You have all the versions of your files stored in these branches. How beautiful. So in this branch banana, let's do some banana work or fix a bug or add a feature or whatever cohesive amount of work is related to that branch. Let's do it. So for example's sake, so add the word banana, then git add, git commit, and git log. Now in the log, we don't see the apple branch anymore, but it's still there. So we just need to give the --all flag to git log to be able to see it. And to really see how these branches relate to each other, let's do git log --all --graph --one line. And Git does a brave effort trying to print a graph using ASCII arcs to you. And now we see the banana and apple diverged. We can still switch between these branches and see the file changing. So apple and main. And the file changes according to what we have checked out. Now, let's say that in this project specifically, the main branch is the one where we merge all the work done by our team. So let's pretend that the rest of the team added a test directory to the project containing a file called test1, then added and committed it, and then a test2 file and then added and committed, so we have 2 new commits coming from the rest of the team. And now our log looks like this. I know it doesn't look very beautiful, but you get used to this. You don't need any other fancy tool to show you the log. This is good enough, and I promise after a few times that you look at this graph, you'll get used to it. But for now, just notice that we have these 3 branches starting over here and all of them diverging. And now let's say the work on the banana branch is done and we want to merge it into main. How do we do this? Well, it's simple. Make sure that head points to main. Good, so now we're on main. Now type git merge banana. You get thrown into an editor to edit your merge commit message. The default editor is Vim, which is a little tricky, but for now just type :WQ for write and quit. You can see what you're typing at the bottom here, okay? Look at the log now. Well, Git creates what's called a merge commit that has 2 parents, and the main branch is now pointing at this new merge commit. And the banana branch, on the other hand, stayed where it was. Now, this is going to be a little bit mind-bending, but let's switch to the banana branch and merge main into it, okay? Now, this time around, Git did not create a merge commit because banana was already part of main, so that's what's called a fast forward. And now we don't need the banana branch anymore because the work is done, so let's clean it up. So let's check out main and git branch -d for delete banana, and the banana branch disappears, goes away. Finally, let's say that the work on the apple branch is also done and we need to merge it into main. So let's do git merge apple. But now Git says that there is a merge conflict. Why is that? Well, the reason is that the banana work is conflicting with the apple work. Both of them try to change the same line in the same file. This is a merge conflict. Git does not know how to make sense of that, so you need to help it a little bit. So to fix this is simple. You see these strange things going on in the file. You see what was on your branch and then what is coming from the other branch, and you can decide what to keep or what to delete. So let's clean this up. Remove the strange lines, and now we choose apple or banana, up to you. Or maybe we want to keep both. So let's do that. And now git add file1 to tell Git you've resolved the merge conflict. And finally git commit. And we see that there is a merge commit in our log. Great. Some people dislike merge commits because it makes history look a little bit confusing when you look at it. There's another way of combining work done in different branches that does not create merge commits, and that is called rebase. So again, let's create a branch to add more features to our project. We create and check out branches so often that Git has a shortcut for that. Well, Git has a shortcut for everything, but for creating branches and checking it out, you do git checkout -b and then the name of the branch, say fruit salad in this case. Git creates and checks out the fruit salad branch. Great. So first add oranges to the file, add and commit. Let's also add melons, and we can add and commit that in one go with git commit -a. That means add everything that was changed and commit in the same operation. And the commit message stays there the same. And let's, just for the sake of it, add one more fruit, say peaches. Great, so now we have these 3 commits going on in our fruit salad branch. Meanwhile, the main branch is also receiving updates from our colleagues, so let's fake that. Git checkout main, some more tests were added to the project, so git commit -m and a message, and now the git log shows that again we have a main branch and a fruit salad branch that are diverging. So this time, instead of using git merge, let's do a git rebase main fruit salad. So we're trying to rebase the fruit salad branch on top of main. Now look at the log. The entire fruit salad branch moved on top of main without a merge commit. Each project usually chooses whether they follow the merge or the rebase strategy, and neither is wrong or right. It depends on the project, and frankly, it's a matter of personal preference. And that's it. Well, there you have it. This is most of your local Git workflow. But if you want to collaborate with other people using GitHub, GitLab, Gerrit, then you will love the next video that explains everything about working with remotes in Git. But for now, that's it. Don't forget to subscribe and watch this video over here. I think you'll really enjoy it. Hej då!